Moore's law is a prediction which suggests that the number of transistors on a silicon chip will double approximately every 2 years. A similar acceleration is observed in the data storage capability of electronic memory devices such as hard drives or USB sticks. Simon Elliott from the Tyndall National Institute in Ireland is working within the EU research project REALISE on the next generation of USB flash memory.
Improvements in memory chips are now only possible by bringing in new materials that can be laid down with the high quality needed. And the advances that we made in the REALISE project are going to allow more data capacity in flash memories and faster transistor operation.
The new materials are rare earth oxides, a fine powder that functions as an electronic insulator. It will isolate the electrical information on computer chips. ASM in Helsinki, Finland, has developed a new atomic layer deposition process to apply the material onto a silicon wafer. The wafer is loaded into a reactor. Inside, the rare earth oxide is deposited onto the wafer surface, layer by layer, in a controlled way. These repeated chemical reactions lead to a thin, uniform 3D coating with thickness in the nanometer range. The advantage of a 3D layer is the possibility to pack the information closer on a given surface area. This leads to a higher capacitance of the electronic memory. Experts are talking about a higher K value of the deposited films. Dr. Marko Tuominen has supervised the process at ASM.
In this project, we wanted to make material with high enough K value to achieve high enough capacitance value in these devices. And we could successfully integrate these films into 2-dimensional or 3-dimensional structures.
The electrical tests were done at Tyndall National Institute in Cork, Ireland. To measure the capacitance, a voltage is applied across the rare earth films on the processed wafer. The results are promising, so that this process will enable engineers to create the memory chip of the future.
The trend is moving towards 3D, and this process can be used in 3D. So what that will deliver is lower cost and higher performance on a given surface area. And that's what's needed for the future of the electronics industry and to continue to follow Moore's law.
The REALISE project has developed a technology that is now ready for industrial application. It is the basis for manufacturing a 1 terabyte USB stick that could store more than 130 hours of high-definition films in your pocket.